Hey, this is Don from Padlock Technologies again. We are going to do another whiteboard video, but we are going to start talking about inter-AS MPLS L3 VPNs. Now, there are four types of inter-AS VPNs. One is really an unknown method, or people really don't know about it so much. I'm going to talk about that. But what we're going to do is the theory part first before we go into the lab. You guys know I like to tell you the theory of everything before we go in the lab, because if you don't understand how the technology works, just showing you the configurations does not help you pass exams, doesn't help you in the field. You need to know how things work from a theory perspective in the brain so that the configurations makes more sense. I always say know the why you're doing something before you know how to do something. So let's start the conversation here. So inter-AS MPLS L3 VPNs is a method of combining two separate ASs into one logical AS per se. And it's not, I'm gonna put quotes around that, because what you're technically doing is, let's say you have AS1, AS2, service provider one, service provider two. You have a company that uses service provider one in some areas, service provider two in other areas, and you kind of want to logically stitch those together into one logical LSP to get information or get data from one side to the other side, but technically they're going to two separate AS. I'm going to draw this on the whiteboard, on the blackboard, so it makes more sense. Um, it does take some coordination to get this done. Now, the four methods are: there's option A, B, C, and D. D is the one that most people don't know about. They know about option A, B, and C, especially if you're going for something like a CCIE service provider, or you work in the service provider space. You know about these different options for inter-AS, MPLS, L3 VPNs. You can even do it with L2 VPNs as well, but we're going to talk about L3 VPNs for now. Now, in this video, I'm just going to go over option A and B. Next video, I will do C and D from a theory perspective, and then the following videos will be the actual lab versions of all four of these different MPLS inter-AS L3 VPNs. So now that we're at the whiteboard here, the blackboard, what we're going to do is we're going to start with inter-AS. I'm just going to say option A. I'm not going to put the whole MPLS L3 VPN. Option A. This is the simple method. Out of all the methods, this is probably the simplest method. Now, there is a scalability issue here that I'm going to go over. And the scalability issue is why a lot of people do not choose option A. Now, caveat, or I'm going to preface this before we get to option D. Option D is combining option A and option B together. So the same scalability issue that you have in the original option A is going to be in option D. All right. So from scalability standpoint, we're going to focus on option A. So option A is going to have, and we're going to do, make sure we can see here. Say this is service provider one. This is service provider two. Company over here, company over here. All right. They're connected in. And then there's a line that connects the two ASs together, right? The two service providers together. So obviously this is going to be an MPLS network. This is going to be an MPLS network. Now, the key to get this to work is this MPLS network needs to be LDP based. Segment routing I tried to do this with segment routing. It does not work. And from what I've seen, it does not work. If someone wants to put a comment or something like that to get it to work with segment routing, I haven't seen it. So that's why every time you see these options, they're LDP based. And what this does in option A is you'll still have your, CE here, CE here. Let's just pretend that there's a PE that this is connected to. There's a PE over here that this is connected to. Now, when you want to get traffic from CE1, let me just put CE1 and 2. When you want to get traffic over to CE1, it will go through service provider A's network, MPLS network, perfectly fine. When it gets to the egress CE or the egress PE, well, I don't know why I said CE there, but when it gets to the egress PE, these two treat each other like CEs technically, right? So the PHP process happens, pops off the transport label, gets down to the PE, the service label is popped off, and then this is treated as normal IP traffic. Now this could be IPv4 or IPv6 if you want to do IPv6 stuff, right? So they treat each other as CEs, right? Now these are technically going to be called ASBRs because they're going to be in different autonomous systems, basically BGP ASNs. And when it pops out, this traffic is no label on top of this, no label whatsoever. So this is strictly IP traffic. So you can either, do some type of static routing, or you could do BGP under the VRF and just share the routes that way. But when it gets to here, when it gets from PE, egress PE to this ingress PE, it's all IPv4. Then when it gets into service provider two's network, it gets back to being labeled. So this traffic gets labeled all the way to the egress CE. PHP happens at the penultimate router. Ultimate router has the VPN label. When it pops off, that becomes regular IP traffic here, regular IP packet. So this is regular IPv4.6. Right here is regular IPv4.6, right? IPv4.6. So it's MPLS all the way to the egress PE or the ASBR, turns into IPv4 non-labeled traffic, goes into the next service provider, and then turns into labeled traffic again. Then when it pops on the other end, gets to the egress PE from service provider 2, turns into the normal IPv packet, and then it gets to the CE. Simple inter-AS design, right? Doesn't have, not too complicated. As long as you know what MPLS is, how to configure it, how to configure, you might have a route reflector here or there somewhere in there. But as long as you know how to create or configure MPLS, LDP based MPLS, then doing option A is pretty simple. Now, where's the scalability problem here? So the scalability issue is the number of VRFs you have. So let's say, for worst case scenario, let's say you had 200 clients, right? 200 clients. Well, that would mean you would need 200 VRFs, right? And then 200 sub interfaces. For the most part, you're going to use subs. So you're going to have 200 sub interfaces to match those 200 VRFs. So you can see, if you had 1,000 customers, having 1,000 sub interfaces, you have a scalability problem right there. Eventually it gets out of control, right? And if you're a service provider, or you're kind of a if you're a tier 3 or the tier 3 technically, because tier 2s and tier 1s are a different kind of pairings. But let's just say you're a small ISP and you're trying to provide MPLS services to your customer. If you go with option A, you're going to have a scalability issue once you reach a lot of customers. That's why a lot of people don't even do option A. Now, from a security standpoint, now when I say security, I mean traffic separation. If you watch my video before on Get VPN, you know that MPLS is not secure by default. It provides traffic separation, but it does not provide encryption. You need Get VPN to actually provide the encryption piece, right? So this is the most secure because all traffic is separated, right? If you have VRFs and you do BGP in the middle between the service providers, well, that traffic is separated with different routing tables. So if you have 200 VRFs, you have 200 routing tables technically, and nobody sees any routes, right? So you have that as a security standpoint. But the drawback of that is scalability, right? But this is the easiest one. Something that you would have to do in like a CCIE exam or something like that. If they say, hey, we want you to configure this, once you configure the inter AS option that provides the most security, but not as scalable, then you're going to option A, right? Because it provides the most security, but it's not scalable. Now, the likelihood of them wording it like that is probably slim to none. right? But just know this is option A. It's more secure, but it's not as scalable. So very simple design. But let's now start talking about option B. So option B, right? Enter AS, option B. We're gonna have the same design here, different configurations, right? So we have, ISP1, ISP2. Let's say we have the link between them, and this is just a theoretical link. It could be tons of links for this. We have CE over here, CE1 connected in, and then CE2 connected in. We have our ingress PE, our egress PE on both ends. MPLS, MPLS. Now, what is the difference between option A and option B? Well, option B actually forms a VPN-v4 or VPN-v6 adjacency between the PEs. So here, you're actually going to form a BGP neighborship under VPN-v4 or 6, right? Now, because you're doing that, this is no longer going to be IP packets, right? Normal IP packets, right? This is going to be labeled traffic going from, AS1 to AS2 between the ASBRs. Remember, these are ASBRs here. So ASBRs are not just an OSPF thing. It just means the autonomous system border router. So if you are doing neutral redistribution between OSPF and EIGRP, that's an ASBR. If you are doing some kind like we're doing here between ASN 1 and ASN 2, that router that connects the two is an ASBR. So ASBR. Now between the two ASBRs, you have this VPN v4, AFI sub AFI. Remember, AFI is the main thing, which is IPv4, or say AFI sub AFI. If you don't know what that is, say if I was doing IPv4 unicast, IPv4 would be the AFI, unicast would be the sub AFI, right? Or multicast would be the sub AFI, but IPv4 would be the AFI. So we're talking about VPN v4 or 6 here. That's the neighborship that you're going to have. Now, when you do this on iOS XR, this doesn't do it by default, right? On iOS XE, it does it by default. So when you turn on or activate that neighborship, what's going to happen is under the interface that is connected here, you're going to see something that says MPLS BGP forwarding. And what this command does is it's going to use BGP to create labeling between the two ASBRs. So the PEs that are connecting the two sites together, it's going to allow labeling to form there via BGP, right? Now, what this is called is segmented LSP. So what segmented LSP is, which is label switch path, for those of you who don't, that's MPLS terminology, label switch path. What's going to happen is in ASN, whatever this ASN, you're going to have one LSP here. Then you're going to have another LSP here. And then you're going to have an LSP here, right? This is where the segment, like you have segmented LSPs because there are 3 LSPs that are being stitched together to look like one LSP. So what happens is, from a labeling standpoint, when traffic goes from this in this direction, so from CE1 to CE2, labeling will happen like normal. It will get to this ASBR, and then they will have their own labeling that goes from here to here. And then when it gets to another PE, the next PE in the other ASN, it will have its own labeling, right? But it will look like one LSP from the outside looking in. But technically, the labeling is going to be segmented out, right? So it's going to be stitched together, but it's going to be different LSPs, right? And the LSP between the two PEs or the ASBRs have nothing to do with the LSP in its respective service provider. And that's option B. Now, what is the advantages of doing option B? Well, option B is going to get rid of the scalability issue that option A has, right? You no longer have to worry about having, 200 VRFs and 200 sub interfaces. And every time you add a customer, you got to have another VR. Like, you don't have to worry about all of that, right? Because now you're just going to use the LSP that's created, or the segment of LSP that's created between service provider 1, ASBR, service provider 2, right? Now, from a security standpoint, it's only sharing the VPN v4 table. So you're going to be sharing that VPN v4 table between the ASBRs, because you're going to have that VPN v4, v6, whatever you want to use, adjacency there. So that VPN v4 table is going to be shared. But again, from a security standpoint, you don't have the traffic separation that you have in option A, because technically there's no VRFs. The other thing that you have to worry about is, let's see here. The other thing you have to worry about is from the ASBRs, right? You do have to do this by default. There's a rule in BGP that says if you don't have a VRF configured on the actual router itself, it does not advertise the routes. Right, so you have to worry about that. So what you have to do on these ASBRs is, what color I want to use? Let's use red. So on these ASBRs, you have to do, and let me see if I can remember this off the top of my head. I think it's no BGP, I think default route filter. And that command under the global BGP process, that command actually removes that rule that says, hey, I don't have a VRF configured for this, so we're not going to share the VPN v4 tab. You're not even going to know, you're not going to advertise anything to the other PE, right? Because you don't have the VRF there. You have to put that command in, because if you don't, you're going to run into problems, because whoever you're advertising to won't get the routes, because technically these ABRs here won't have a VRF configured for it, because you're only doing VPN v4 adjacency. So that is Enter AS option A and option B from a theory standpoint. Like I said, in a CCIE service provider exam or in the real world, they might ask you. Now, most of the time, if you're not working for a service provider, this probably won't come up in the enterprise network unless, they really want to just quiz you on it for some odd reason. But if you're going to work for a service provider, they're definitely going to ask you about this Enter AS options, which one is better, what would you use and why. And if you're a consultant, you definitely need to know this from a theory and configuration standpoint, because if you're helping somebody out, if they want you to sit into a meeting talking to the service provider, and they are dependent on you to listen to the options that the service provider can offer, and they're dependent on you to give them the answer, well, you need to know the difference between option A and option B, option C and option D, right? So this is Don from Padlock Technologies. I hope you enjoyed this video. Don't forget to share, comment, like, and subscribe. Be on the lookout for the next video that is going to be on Enter AS option C and option D. This is Don from Padlock Technologies again. Thank you and have a nice day.